Greetings of the day, dear students. Today we are here to discuss about experiment number 5, RC phase shift oscillator using transistor, which comes in the course PCB design and fabrication lab under the program Electronics and Communication Engineering for semester 5 diploma students. So we will see the PCB design part in this experiment of RC phase shift oscillator using transistor. Let us see the circuit diagram. Okay, so your circuit diagram looks like this. Okay, it requires a transistor. Okay, then three RC elements. Okay, for RC phase shift oscillator, and one resistor, one capacitor at the emitter, one resistor at the base, one resistor at the collector, and one resistor for taking the output, and VCC and ground component I require. Okay, so apart from that I require for measuring the output a two pin connector, and for giving VCC and ground another 2-pin connector I require. These are the components. Okay, so let us begin first for designing the circuit. Okay, first as usual you have to click on this icon, that is keycad icon. Then as usual file, and then new blank. So in that you name the you give the name RC. For example, I will give 22. Okay, I will give the name for the experiment, right? Save it, then say yes. Okay, a new project has been created. So now I want to draw the schematic first. I require an editor. So click on this first icon, that is eSchema. So I will get an editor. So here collect the components. Okay, first I will take the transistor. You place a component, go here and click somewhere here, then search list all and search for transistors. Okay, here is the transistors. Then take the transistors. In that there are several transistors. Let us select BC547 transistor. I have selected BC547 transistor. Okay, so where I have keep it somewhere here, right? Then I require resistors. Okay, let us take resistors, list all. Then resistors are present in devices. Take that resistor from the device. Then here it is there saved under the name R. You take resistor R. Okay, then keep it here, right? So then you select copy the resistor, place, and again copy, place. Okay, so copy. I require here one more resistor. I require here one more resistor here. Okay, I am copying all the resistors and placing near the different terminals of the transistor. Okay, so one resistor here, three resistors, I think 1 2 3 4 5 6 resistors I have selected. Okay, then select capacitor. Okay, so I am selecting capacitor now. So for that I will move a little bit more. Okay, then again here place a component, then list all. Capacitors are present again in devices. Then it is saved as C. Take capacitor C. Okay, this is C. You place the capacitor. Okay, let us place the capacitor here. I am selecting 3 capacitors, 3 resistors for RC phase shift, right? Then place it properly. Then I require 3 capacitors here, one more capacitor at the collector I require. Okay, so I am again copying this capacitor. I require at the collector one more capacitor I have kept here. Okay, 1 2 3 4. Okay, so then I require, just see the circuit diagram once again, 1 2 3 here and 1 4 here. One more polarizer capacitor I require. Okay, so I will select now polarized capacitor near the emitter, that is select the component, then list all devices. You select CP, polarizer capacitor is saved as CP, then take this. Okay, so these are the capacitors, right? So 1 2 3 4 5 capacitors are there. Then I am arranging okay. Right, so then I require one 2 port 2 pin port, okay, or 2 pin connector. So then go here, that is place a component, then list all, in that go for CONN and then say okay. So connector 2, you just search for connector 2 pin connector means it is saved as connector 2. Here it is, I have selected connector 2. Okay, so connector 2 is used for taking the output. I will be keeping here. Okay, so for output, and another connector 2 I require, that is same thing. I will copy and place anywhere here for connecting, for taking VCC and ground. Okay, so 2 has come upward, that's why I am taking the mirror image. Okay, orient. Okay, so now these are the components I have taken. Then I require VCC and ground. Okay, VCC and ground are present in this icon, that is place a power port. So then say list all. So here you will get VCC, you search for VCC. So you take VCC for example. Okay, place near this port anywhere. Okay, then again same thing, place a power port, go here, list here, instead of VCC you type GND ground. Okay, or else list all. Now here you type GND ground. Okay, so you can select that ground. Okay, so I will place, I will be putting here for VCC and ground. Okay, and for each one I require a power flag. Again select this, place a power port. Okay, then list all, power flag PWR, I will type PWR here, power underscore flag is there, then take this. Okay, place one near VCC, then same thing you copy, and I will be placing one near ground. Okay, so I have collected all the components, right? So now start giving the connection. Then for giving the connection, take the wire here, place a wire. Okay, so you hold the circuit diagram in your hand so that you can connect the thing. Okay, that is first these 3 capacitors I will be connecting. Then this resistor is there, you connect these 3 resistors here. I am connecting this. This resistor at the base and this resistor at the collector and this resistor at the emitter, and this will be at the collector capacitor, and for taking the output I am connecting this, and one end of this capacitor will go connected to emitter, and there is a feedback from output to input. Okay, that is I am giving the feedback. So then to connect these two ends, these two are also connected. Okay, so then connect ground points below. This is also connected to ground. Okay, and this is also connected to ground. So in this way, and this is also connected to ground. Okay, so and one VCC, and here at ground I require. Same thing you can copy it here once again. So here VCC I am connecting it to this, and ground I am connecting it to this, and this power flag is connected to VCC. This power flag is connected to ground. Okay, then I am copying VCC, copy C, and VCC is required at the collector end, or else you can take the wire from this up to there. Okay, both are same. So then take the wire, connect VCC at the collector point, and again copy the ground. See, I am placing anywhere here to connect this to the ground. Okay, so this is the circuit diagram or schematic. It is called drawing the schematic layout. Okay, here the wires are crossing. Okay, so they are not connected. Whenever the connection is there, a junction will come like this, right? So this is the schematic connection is over. Then what you do is you save the schematic, then go for annotation. Okay, so here annotation, click here annotation, then say OK, then say close. So each resistor and capacitors are named as C1, C2, C3, C4, R1, R2, R3, R4, and so on. Okay, so these ports are named as P1 and P2. Okay, so I have saved, I have annotated. Then next is perform electric rules check. For that, test ERC. You click here, so it is showing no errors. Okay, if any errors are there, then here error will come. Okay, so error checking is over. Then next is net generation. Okay, so net list you click, RC22 it will be saved with extension .net, save it. Then association of the component you do. Okay, so here the association will come. So for each one, okay, for capacitor C I will let us take C2, 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 or you can even take C3, C4 and anything. For CP polarized capacitor you take CP4, and again for capacitor C I am taking C2. Okay, connector 2 I am taking it as SIL2. Okay, here is there SIL2, and next SIL2, here it is already coming T092. Then for resistor R I am taking, for example, R3 you can take. For all resistors I am taking it as R3. Okay, so in this way footprints I have associated. Then save this file, save, then come out of this. Okay, so this will be the next step. Okay, in this way I have associated all the components with their footprints. Okay, so then you can give the name for this. Okay, so this is power supply port, okay, or power supply connector, and this is output connector. You can give the name also. Okay, so then next is PCB. So this is schematic is over. Now I want to take this to the PCB layout part and draw the tracks. Okay, for that you have to click here, that is run PCB new to a layout printed circuit board. Then say PCB new is already okay. say okay, you say yes. Okay, then go here, okay. So then you have to run PCB new, okay, then say okay. Next what you have to do is, when you come here, you just first step is you then net, okay, read current net list, then you say close. Here your circuit diagram has come, okay, you can see here the circuit diagram is present here at the corner of your window, okay. So then what you have to do, so click on this, that is mode, footprint, manual and automatic, move and place modules. You click on this and come here, right click on this, okay, globe, move and place, move all modules, then say yes. Okay, so here these components all are present. Okay, now arrange them properly. Okay, I will take this transistor, okay, I will rotate, okay, keep it, then you see the circuit diagram, okay. So I will see once again the circuit schematic. Here C1, C2, C3 from this end. So therefore arrange accordingly, so that for drawing the schematic it will be easy. You see where is C1, okay, take C1. Next take C2, here it is there, take C2, keep along with that, then take C3, so that it will be easy. Okay, then take P2 at the this, you just check that 1 minute, I will check. Here it is C5 and port 2, C5 and port 2 you take. C5, so sorry, C5, here it is there, C5, move, okay, it is at the collector side, C5, then P2 is also there, take this and move here. With this, okay, I have taken port 1, sorry, you take port 2, okay, this is port 2, move. So here it is there, port 2, right. I am keeping this, okay. Then take the different resistors now, okay, one by one. Okay. So I will begin with this resistor, take this resistor, keep it here. Then resistors generally I have kept vertical, okay. I will be keeping, okay. So move this, see where it is connected, it is connected here, okay. Then take another resistor, say move, let us see where it is connected, it is connected here. You can keep like this and take next resistor, okay, see where it is connected, I am seeing where this resistor is connected, it is connected here. You can keep like this, okay. So then take this resistor, it is connected at the emitter side, okay. I will move this capacitor C4, C4 is also, I think it is at the emitter, okay, move it, okay, right, it is at the emitter. With this, I think this resistor is there, you have to see this, move move this and move this from here. Okay, so you have to move this, you have to move, keep it here. Okay, so then take this resistor, move it here, see where it is connected. You can, yes, it is here, you can keep it. Okay, so then one more resistor is there, take this and move it here. Okay, so keep it here. So in this way I have moved all the components. Okay, so this is what the final diagram will appear when I move it. Now placing the track on this. Okay, place the track. Okay, for placing the track you select this, add tracks and vias. Okay, so you start giving the connections. Okay, I will start from here, connect it. So click here, connect it, click here, connect it, click here, connect it. Then see here, it is going to ground. This is ground point. Okay, go here and connect it here. Once again I will go here, and connect it to ground, and then connect all these wherever white wires are there. Connect this, see here, connect this, one minute. And now you connect it here, you are seeing here, you can connect it here and just see where they are remaining. Okay, you can connect this white line, complete it. Then you can connect this white line and complete it, and then you can connect from here, connect it and see where this is ground line. Okay, go here and straight away you can connect it to ground line, and then you can see here, from here it is feedback. So therefore you see here, from here this is going to emitter, you can connect it to the emitter. Okay, so I can connect from this point directly to the emitter. You can connect it here, you can connect it. Then you can connect from this emitter to this point, and from here you can connect to this point, and see one more feedback point is remaining. Okay, that is from this it is connected. You can check here again, from this to it is, there is a connection to here, and from this already connected it is. So there is a feedback from one more line is remaining, that is feedback line. Okay, from this click it correctly, that is from there is a feedback to the collector. You can go from like this. Okay, so now all the connections are over. You can see no white wires are remaining. So in this way this is the output. You can see that is oscillator's output is here, and you can give VCC and ground at this point, that is power supply port. Okay, so this completes the PCB, that is drawing the tracks on the PCB. Now just to finish it, I have to go for marking the boundary. For that I have to select F mask or F silk, you can select F silk layer, you select, then select this line for drawing the add graphic line and polygon, then okay, you draw the line here. Okay, I will draw the line for putting the boundary mark. I am zooming so that I can double click to finish the boundary. Okay, so then you have to put the text here, give the name, that is back copper you go, and give the name for this, that is this is RC oscillator. I will give RCO. Better if you give in capital letters, it will be more. RCO, I am giving the name RCO. Okay, so that is, it will be coming in mirror image, you can keep it here. Okay, so this completes the design part of PCB layout of RC phase shift oscillator. Okay, so I am clear. Thank you for giving me an opportunity to share my views with all of you. Okay, thank you one and all.